All right, today we're going to be looking at our polar coordinates day 2. And today we're going to be using equations. So the other day we converted from rectangular to polar and polar to rectangular for coordinates. Now let's do the same thing for equations. So to convert from a rectangular equation into a polar equation, that means that you're going to be seeing x's and y's. And so it makes sense then that what we're going to do is replace x with cosine theta and our r with sine theta. And anytime that we see x squared plus y squared, then we can put in r squared for that, all right? Then we can solve for r or r squared so that we have a function where basically r, so r is a function of theta. Okay, so let's convert the rectangular equation to polar form. So notice I have 3xy 3x minus 6y plus 2 equals 0. And so I notice that I have 3. And then in place of the x, I can put r cosine theta minus 6. And instead of the y, I can put r sine theta. And then I have plus 2 equals 0. Okay? So again, our goal is going to be to solve for r. So let's maybe think about it like this. So even though we notice that we have r in here, you might want to kind of think about pulling like an r out. Oh, oops, no more r. So we'd have r times 3 cosine theta, and then minus r times 6 sine theta. And maybe let's pop this guy to the other side. So we have negative 2 over there. So what we can do is factor an r out. And again, you don't really need the stuff I just had. But if you factor an r out, we end up with 3 cosine theta minus 6 sine theta times r equals negative 2. And then we want to isolate r, so we get r equals negative 2 over 3 cosine theta minus 6 sine theta. And that should be okay. I guess I could factor a 3 out of this, but since it doesn't cancel, I'm just going to leave it. Anyway, so what you're going to see is that this ends up being a linear equation. And I know that that looks horrid for us, but if you guys look, notice that that is an example of a polar equation. Okay. Right. So anyway, so something like this, we're going to see ends up being a linear equation. So let's see what happens if we have x equals 4. If we have x equals 4, then that means that in place of x, we're just going to put that r cosine theta equals 4. Now let's isolate r. We get that r is 4 over cosine theta. And because this is a singular trig function, there's a better way for us to write this. Instead of 4 over cosine theta, isn't 1 over cosine theta secant? So really we should write this as r equals 4 secant theta. Okay? So we're going to bring up, if we have a singular trig function, we're going to bring that up. We didn't do that here because we had a bunch of stuff in the denominator, but here it's pretty easy for us to bring up. Okay? And so notice that this gives us a vertical line. All right? So let's take a look at number 3. Oh my goodness, look, I'm going to have to square this. Well, we don't, because I want you to notice that this x squared plus y squared is replaceable with r squared. So the x squared plus y squared we can replace with r squared. And now I have minus 2a, and then in place of y, I can put the r sine theta equal 0. And so let's factor out an r. And so if I factor out an r, since I have 1 in each term, I have r times r minus 2a sine theta equal 0. So now technically our goal we said was to solve for r. So one of these would be that r equals 0, but remember r equals 0, what this would be is the pole itself. So we just disregard that. Okay, so if we get something like r equals 0, let's just forget about it, all right? And then what we'll do is we'll take then this idea of r minus 2a sine theta and set it equal to 0 and solve for r that way. So we'll just focus on this guy. And then all we really do is add 2a sine theta. And that would be our answer, that our polar equation would be r equals 2a sine theta. Let's look at number 4. In number 4, we have x squared equals y cubed. And we might try to be savvy and say, well, let's subtract so we can get x. No, so we can't get the x squared plus y squared. So let's just actually replace x with r cosine theta and y with r sine theta. So then what we can do is we can apply the exponent to each piece. So I get r squared cosine square theta equals r cubed sine cube theta. So let's then maybe move everything over to the other side. And I'll put it on this side here. That's a 3 here, sorry. And again, we could have divided by r squared, but it's so scary to divide by variables here. So I put them on this side, so what we could do is factor this out. Factor out an r squared. So we end up with r sine cube theta minus cosine square theta. Okay. I just feel a little bit better about that. So then if we have the r squared equal to 0, then again we have r equals 0, and again that's the pole, so we just disregard it. So now we also have r sine cube theta minus cosine square theta equal to 0. And so what we have then is we can add cosine square theta to each side. Clearly I wrote too big. And then to isolate the r, we could put sine cube theta in the denominator. And let's think about how we could simplify that. When we were simplifying the trig expressions back in chapter 5, your favorite chapter and mine, this is how we could think about it. I know it's been a while. You could really think about this as cosine square theta times 1. And then you could think about this down here as sine square theta times sine theta. And then you can kind of think about multiplying those pieces together. So in that case, then the cosine square theta over sine square theta becomes cotangent square theta, and the 1 over sine theta becomes cosecant theta. And then that would be a happy way to solve for r. So how much fun is it we get to go back to chapter 5 and review that? I know, it's pretty exciting. All right, let's go on to number 5. 4, I think, was the hardest one. So number 5, we have 2 times xy. So, oops, I forgot the r. So I'm going to have 2 times our cosine theta times our sine theta, and then equals 1. So notice I have r times r, which is r squared. And then here I have 2 cosine theta sine theta equals 1. Now you might say, Miss Mackey, why did you put the 2 with the cosine theta sine theta and not in front of the r squared? Well, why don't you tell me? Except I'm not here, so you can't. But look how exciting this is here. 2 cosine theta sine theta. Does that look familiar to you? I hope it does, because once again, we are excited about using our knowledge of Chapter 5. This is a double angle formula. This is really the same as the sine of 2 theta. So what that means is that we can rewrite that using that as the sine of 2 theta. And then if we isolate r squared, we get r squared equals 1 over sine 2 theta. And here's a singular trig function in the denominator. So let's write it as r squared equals cosecant of 2 theta. Okay. I know, such exciting stuff. I'm so sad I'm not here. All right, next, number 6. We have one more that we're going to go rectangular to polar. Then we'll go the other way. So I notice that I have y squared and I have x squared. And look, if I add x squared to this side, I have x squared plus y squared equals 5. And if I get the x squared plus y squared, remember I can turn that into r squared. And so I have r squared equals 5. And so notice that this is the rectangular equation for, this is the polar equation then for an idea of a circle. And you can write it as r squared equals 5. I guess you could do r equals root 5 too if you want. Like, that's fine. Either one is okay. All right? So that is how we go from rectangular to polar. So now that we've done that, let's convert the polar equation to rectangular form. And so to do this, anytime we have, we see an r cosine theta, we're going to turn that into x. And anytime we find an r sine theta, we're going to turn that into y. And anytime we have an r squared, we're going to turn that into x squared plus y squared. Okay. Now the problem that we might see is that these might not exist like right away for us, so we might have to create them, okay? So we might have to be creative. So we may have to create these guys, okay? So let's look at example 7. 7, we have r equals 4 sine theta. I don't see any of these at all. So what's something that we could do? Well, one thing that we could do is we could multiply both sides by r. Notice that when we have that, we end up with r squared, and then we can look at this as 4r sine theta. So by multiplying by r, notice that I created an r squared, which could be x squared plus y squared. And I created, color code, and I created an r sine theta, which turns into y. Oh my gosh, we got rid of the polar coordinates and turned it into rectangular. One thing I was told is that to get the equation equal to 0, so because that technically is the general form that we want it to be in, okay? So the last step that we would do is just subtract 4y and have it look like this. So we don't have to complete the square in these, even though that would be pretty fun, wouldn't it? All we're going to ask you to do here is put it in that general form. Okay? Let's look at number 8. In number 8, if we multiplied by r, we would get r squared equals 4r. And I've got something for r squared, but this 4r, I'm kind of stuck. So what we can do instead, because the 4r on this side was problematic, what we could do is square both sides. And squaring both sides, I get r squared equals 16. So now that you have r squared, we can replace r squared with x squared plus y squared. And that's rectangular. So now we just subtract 16 so that it's in that general form equal to 0. Okay? So kind of what we looked at here, notice that I tried to multiply by r and that wasn't a good plan, but squaring worked. Let's pretend you tried to square this guy. If you had tried to square this guy, you'd have r squared equals 16 times sine square theta. And then see how once again you're stuck? So sometimes you might have to try one or the other. If and again, like after you do more, it'll become a little more instinctual which one. But basically, if you get stuck, then try to do the other thing. Okay. What about theta equals pi over 6? Well, let's think about that a little bit. We know that from what we talked about before, that the tangent of theta is going to be y over x, right? So if we don't have any of these r cosine theta, r sine theta, or r squared, this time we didn't have any r's, we just had a theta. Let's think back to this also. So then we can say, all right, well then I know that the tangent of pi 6 is going to be y over x. Okay? Well, I know the tangent of pi 6. I know the tangent of pi 6 is root 3 over 3. And then now I could cross multiply if I wanted to. So I could get root 3x equals 3y. And then I'll just get that equal to 0. Root 3x minus 3y equals 0, and that's that. So in this one, I didn't use any of these guys up here, but I still use my knowledge that we looked at of that relationship between the rectangular and the polar coordinates. All right, how about number 10? We have r equals 5 cosecant theta. Well, you guys remember that cosecant is like 1 over sine theta. So we could rewrite that as r equals 5 over sine theta. And then why not multiply both sides by sine theta to get that r times sine theta equals 5. And then look, r sine theta is the same as y. So I have this y equals 5. So we've got that nice horizontal line, but let's make it equal to 0 so that we're consistent with the other problems. Okay? See, this isn't bad. It's just basically plugging and chugging away. I think it's kind of fun. All right, so how about this one? Number 11. Well, again, in this one, you might get excited and try to square r or multiply by r, but why not just try to basically multiply by 3 sine theta minus 5 cosine theta? So I get r, basically r times 3 sine theta minus 5 cosine theta equals 8. Of course, then this becomes 3r sine theta minus 5r cosine theta equals 8. And look, we've got an r sine theta and an r cosine theta. So we're able then to replace those with y and x respectively. And now we want to get one side equal to 0, and it doesn't really matter. But you guys, in a lot of textbooks, a lot of times they prefer the x to be positive. So I'm going to move them all over here. Is that okay with you guys? So then I'm going to have 5x minus 3y plus 8 equals 0. Okay. Looking good. All right, let's try number 12. So in number 12, I'm going to, once again, let's maybe multiply by 1 minus sine theta. So I get r times 1 minus sine theta equals 1. Okay. So if I distribute the r minus r sine theta equals 1. Let's see here. Well, I can turn this r sine theta into y. So I have r minus y equals 1. Problem is, we've got to get rid of this r somehow. So if we look back, if we could make that r squared, then we can be talking here. So let's move this y to the other side. And again, we want this to be r squared. So let's try to think forward. Would it make more sense to multiply by r or to square it? Well, if we multiply by r, we're introducing another r over here, and that was our issue. So I would suggest squaring both sides. So if we square both sides, then I have r squared equals, and then I have this y plus 1 squared. And the reason we wanted r squared is because r squared can turn into x squared plus y squared. And then over here, I guess I'll flesh this out. This gives us y squared plus 2y plus 1. And look, now everything is in the rectangular variables x and y. So if I try to get one side equal to 0, look, you guys, the y squareds cancel out. So I have x squared minus 2y minus 1 equals 0. And there we go. Okay, one more, and then you guys can get started on homework. Okay, so let's look at this one here, number 13. So notice I see here that I have r squared equals cosine of 2 theta. Well, I like the r squared, but this cosine of 2 theta thing might be a little problematic. I'm not really sure what I can do there. One thing you might be able to do is use a double angle formula. That might be super fun. So this one, again, takes a lot of imagination. But what we could do is we could rewrite the cosine of 2 theta as cosine square theta minus sine square theta. And then we're going to want r cosine theta and r sine theta. So we need not just to multiply both sides by r, but because I have cosine squared theta and sine squared theta, I'm going to need to put r squared on both sides to do that. Now I know that this is r to the 4th, but we really want to keep things in terms of r squared. So I'm going to keep that as r squared squared. And then essentially this is r squared cosine square theta minus r squared sine square theta. And then again, this is like r cosine theta squared minus r sine theta squared. And look, magically, we have all of our friends that we wanted. We have r squared, which turns into x squared plus y squared that we square. We have this r cosine theta, which really becomes x squared minus, and then we have our r sine theta, which is y squared. And look, now we're totally rectangular. See, it's hip to be square, but I'm not funny. Okay. So if we flesh this out here, we end up with x to the 4th plus 2x squared y squared, yep, plus y to the fourth equals x squared minus y squared, and then we'll just get that equal to 0. So x to the fourth plus 2x squared y squared plus y to the fourth minus x squared minus y squared equals 0. And my friends, that is the practice that we hope is adequate for you guys to attack the homework for tonight, okay? Well, I hope you guys enjoyed this transformation from rectangular to polar and polar to rectangular, and the throwbacks to chapter 5. I know that was your favorite. And good luck. Send me reminds with any questions, okay? Have a great day.